Bismillah ar-Rahman ar-Rahim. I'd like to welcome all of you to this course, Traffic Operations. This course is basically an extension, or we are extending what we have been doing in the fall semester, and it's basically we are completing or following up on traffic engineering, basically. So this course is a complementary course for the traffic engineering course. Okay. Any questions? Okay. So we will start first with the grading and assessment for this course. Of course, the prerequisite for this course is traffic engineering. We will have 2 midterms, each midterm for 20%. We will have a final exam for 40%. Then we will have 2 quizzes, multiplied by 5%. And we will have small projects and homeworks and participation. All of these are 20%. The textbook, we will continue using the McShane and Ross traffic engineering book. And of course, we will be using the highway capacity manual. Okay. Introduction and review. The objective of this course is basically is an integration and to apply what we learned in the traffic engineering course. We are applying traffic engineering and control concepts to enhance traffic operations, safety, and level of service without adding new infrastructure capacity. Okay. Advanced techniques such as traffic flow theory, methods, shockwave analysis, lane management, ITS, and so on. Okay, this course is divided. Excuse me.
I have a question, please.
Okay, go ahead.
Yes, دكتور هذه المادة بتكون ممتدة بالنسبة لمادة الترافيك أو الترافيك والأوبريشن كلهم.
This topic is basically an extension. It's you can consider it as traffic engineering too, or advanced traffic engineering. Okay. Does this answer your question?
Yes.
Okay. Okay. The course is basically divided into module. Could you hold up for a second, please? Back. As I mentioned before, this course consists of a group of modules where we'll be focusing on a specific topic. So here we are focusing on the weaving segment analysis. Okay, so before we start talking about weaving segment, what is weaving segment and why we get these weaving segments, how it gets generated in the first place. So before we go directly into the weaving segment, we will go to what we call grade separation and interchange layouts. Okay. When do we need to make a grade separation between highways and roads? That's a very important question. The answer to this, there are warrants for grade separation. When do we need to separate between the elevation of 2 highways? Basically, when we have 2 or more uninterrupted freeway facilities intersecting together. Okay, when we have 2 freeways, uninterrupted facilities, they are crossing each other. At this point, we must separate their elevations. Okay, there's another warrant for grade separation where an interrupted freeway facility intersects with a regular interrupted facility. To give you an example, if you go on the airport freeway, you will find other freeways crossing on top of that. That's an interchange there, because we cannot interrupt that freeway and have a traffic signal. Okay? To have an example for this, this is an example for a freeway, and you can see this one is very complicated. The disadvantage of these freeways, it takes a lot of space and it costs a lot of money. But sometimes it's unavoidable to use it. Okay, let's study the steps, how we start making separation between these. When we have two freeways or two highways intersecting together, we have 16 crossing points. These are the points in yellow, I'm sorry, in blue. And we have diverging lanes, those are in greens. And we have converging points, these are in orange. So we need to build a freeway such that we eliminate these conflict points. So first, we take the two through movements and we just build a bridge. So this way we are separating the two, through movements for both directions with this elevation. Everybody understand what I'm talking about? Hello?
يعني نشيل التقاطعات ونخليها great separation.
Who is speaking?
هذا اللي فهمته.
مين اللي بيتكلم؟
فهد القحطاني.
فهد القحطاني. بص، هو هنا اللي احنا عملناه ايه؟ عملنا اول خطوة. اوكي؟ احنا هدفنا دلوقتي our objective is to eliminate the conflict points. اوكي؟ وبالاخص الcrossing points. تمام؟ ف first thing what we did, we had the through movements. الموفمنتس اللي هي through movements بتوع الاتجاهين فصلناهم اوكي بكوبري. واضح؟ فالتو موفمنت دول الثرو موفمنتس بتاع النورث ساوث اوكي crossing with a bridge over the east west. اوكي بالخطوه دي we eliminated 12 crossing points or 12 conflict points out of the 16 crossing points. واضح؟ أسوأ conflict points في الانترسكشنز اوكي is the crossing points. فهنا احنا كل البوينتس دي عملنا لها elimination. اتبقى لنا ايه؟ اتبقى لنا البوينتس اللي هنا دول. شايفين البوينتس اللي جوه الدايره؟ عشان بس اكبرها هنا. شايفين الاربعه بوينتس دول؟ الاربعه بوينتس دول جنريتد منين؟ من الليفت تيرن بتاع الموفمنتس. تمام؟ واضح؟ جميل. يبقى اول خطوه عملنا فصل we separated the through movements. اوكي؟ طب تاني خطوه بنحط اللي هم الرايت تيرن موفمنتس نوصلهم، فدول ما فيش فيهم مشكله. على طول ده بيوصل من هنا لهنا وده لهنا، مفيش فيها مشكله. تالت خطوه third step which is connecting the left turn. How we treat the left turn. Here is the problem. Okay, it depends on the traffic volume that we have in the left turn. So in cases where we have a low volumes, where the volume for the left turn is less than 1200 vehicles per hour, we use the indirect left turn. That means vehicle will go this way with the through, then we make this left turns, okay, and goes down there. Instead of going like this. مش هو كان الاول كان بنعمل ليفت تيرن مباشره بهذا الشكل؟ مش هو ده اللي كنا بنعمله زمان؟ ان الليفت تيرن في الانترسكشن بتلف كده على طول، صح؟
ايوه
طب هنا
صحيح.
لا، لان هنا طبعا احنا ايه، دي كده بنخليه يلف من هنا ويلف ويلف تمام وينزل. ده الفيري كومن اللي هو بيبقى زي اللي هو بنسميه كلوفر ليف انترتشينج بهذا الشكل. تمام. الرايت تيرنز اوكي مفيش فيها مشكله. الليفت تيرنز بيعدي ويلف وينزل ويعدي من تحت الكوبري. دي بنسميها indirect left turn treatment، ودي بتتعمل لما بيكون الفوليوم بتاعي 1200 او اقل. واضح؟ This is an aerial photo for a clover leaf where you can see the indirect left turn. Okay, جميل. And this is also a clover leaf with showing the indirect left turn treatment. Okay, but when the volume increases, okay, so when we have a higher left turn movement, left turn volume, 1800 to 1200 vehicles per hour, okay, then at this point we go to the semi-direct left turn. The semi-direct left turn, it needs building two elevations. You can see here, it goes crossing the other direction, the conflicting other direction with that same level. Then it goes over the through movements here, then goes down and merge with the traffic of the other direction. Okay, remember this one was the indirect. This is semi-direct. Okay, and this is for volumes 1200 to 1800. To give you an example, that's an example. Okay, we call this interchange turbine interchange. It's like a turbine. Okay, and here that's an implementation for this treatment. This one also is a turbine, and that's the way it works. This one, I think this one is in Dubai. Okay. And that's a T interchange where we have here two semi-direct. Okay. Okay. But if the volume is greater than 1800 vehicles per hour, then we go to, we don't use this indirect, semi-direct, and we just go with the direct left turn. Okay, so here we make a direct left turn. Of course, this kind of treatment, it costs much, much more than the previous. Okay, the lowest cost is basically the indirect. This is the lowest cost here, because basically you build only one bridge. Okay, the more we go, when we go here, okay, you are building more structures. As you can see here, for example, crossing over here, you have a bridge. Okay, crossing over here for these left turns, these are bridges. This is another bridge. Okay, and here there is one bridge over here, there is another bridge over here. It's not that simple. Okay, here we build even more bridges and higher in the elevation. So that's an example for a T interchange, okay, where we are using two direct left turn ramps. That's an example. Okay, this is a direct left turn ramp, and that's another example for a direct left turn ramp. That's another example, but that's with you know, this is basically a mix of left turn treatment. يعني for example، يعني هنا يا شباب الاتجاه ده عمل indirect left turn، لكن اللي جاي من هنا واللي جاي من الناحية التانية عمل له direct left turn. واضح؟ ليه؟ اكيد الفوليوم اللي كان هنا مش زي الفوليوم اللي هنا. واضح؟ For example, here we have a T interchange, and as you can see, we have here indirect left turn, here we have semi-direct left turn. Okay, so it's governed by the volume that we have in the left turn. This interchange, we call it a trumpet interchange. Okay. There is other more, more complicated interchanges where we can have, a roundabout underneath the interchange to handle the left turns. Okay. But that's if we have the conflicting direction. Okay, for example, if this one was a freeway and that's, this is uninterrupted and this approach is interrupted, okay, we go to that solution. Any questions so far? Okay. Okay, then here we go to section number 2, which is basically capacity analysis and level of service. How can we calculate the capacity analysis? Because basically these interchanges, okay, generates what we call weaving segments. Weaving segments. What are weaving segments? Weaving segments are basically segments of the highway where traffic, wants to go from left to right, and there's another traffic wants to go from right to left in a short segment of the highway. This is what we call weaving segments. Okay, weaving segments can be primarily on freeways. Weaving occurs due to merging and diverging traffic from the freeway. The objective of the highway capacity manual methodology for analyzing weaving segments is to assess level of service. Okay, to give you a better understanding for what we mean with weaving segments, let me just share with you something. The highway capacity manual methodology for analyzing a weaving segment is to assess level of service عن طريق حساب الدنسity. Okay, limitations of the highway capacity methodology. Highway capacity method ليها limitations. ايه limitations بتاعتها؟ Does not take into consideration special lanes such as high occupancy vehicle lane in the weaving segment. Okay, ramp metering. Okay, special operating conditions when oversaturated conditions occur. Effect of speed limit or enforcement practice. تمام؟ يعني مثلا لو في رادار في الموقع او حاجه ده بيكون له تاثير، فما بناخدش ده في يعني الاشياء دي ما بتتاخدش في الاعتبار في الحسابات. Weaving segments on collector or distributor roadways, multiple weaving segments. Okay, weaving segments on urban streets. الميثود بتاعتها ما بتشتغلش. الeffect of ITS technology and weaving segments، الميثود ما بتاخدش ده في الاعتبار. يعني برضو حكايه المالتيبل weaving segments دي اوريها لكم هنا. We can have a look at it. If we look at فين مجمع الكباري؟ ايوه here for example this site it has a multiple weaving. Okay, you have vehicles coming from this side, they are exiting here, and vehicles coming from that approaching here, and this merging. Okay, this is multiple weaving segments integrated together. Okay, and for example here we have traffic coming from that side going to that side. It's different. It's not the highway capacity manual method doesn't work for these kind of complex weaving segments. Okay. طيب الhighway capacity manual method, okay, it has 5 distinct components. Okay, models predicting the space mean speed. يعني احنا دلوقتي هنحاول first step is to predict the space mean speed في weaving segments for different vehicle types. Okay, then we will go to the model description and proportional use of lanes اللي هو اللين usage. قد ايه بيستخدموا lanes for through وقد ايه بيستخدموه for weaving. Okay, وبعد كده an algorithm that converts predicted speeds to an average density within the weaving. بعد كده في method بنستخدمها عشان نحسب predicted speed مع average density موجودة. بعد كده بنعمل definition of level of service criteria based on density within the weaving segments. Similar to what we have been doing in the highway capacity, in the highway level of service. Okay. أي سؤال يا شباب؟ جميل. هنا level of service criteria في weaving segments. اوكي زي ما حضراتكم شايفين هنا. لو بنتكلم على freeway weaving segments لو density less than or equal 6 it's an A. 6 to 12 that's a B. 12 to 17 it's a C. 12 to 22 that's a D. If it's a multi-lane and collector distributor weaving segments, less than 8 is an A, and so on. Okay. The first step that we need to learn, which is basically the weaving segments parameters, the parameters involved in the weaving segments. As you can see here, we have 4 volumes. The first volume, that's the through movement in direction 1. The second volume is the proportion that is trying to shift, okay, or exit from the highway. This volume is basically the through movement in the other direction. And this one is the weaving volume from that other direction. So in other words, if we label here A, and this one B. So what we have here, we have volume from A going all the way through. It's not changing its direction. And there is another volume that wants to change the direction. This is what we call weaving volume. B, we have also 2 types of volumes. We have volume that wants to go straight, and we have volume that is trying to merge with the other direction. Okay, so this is another weaving volume. So here we have VO1 and VO or VO2. That's what we refer to as an outer volume. Okay, and VW1 or VW2, this is a weaving volume. Okay, how we decide which one is 1, which one is 2? The higher outer volume, this is VO1. The higher weaving volume, this is VW1. Okay, then we have L. L basically that's the length of the weaving segment. So if we go back to our example here, okay, where was it? Here يا شباب. The weaving segment في الحالة بتاعتنا اللي هنا in this case will be from this point to this point. That's L. النقطة اللي بيبتدي يحصل ميكس ما بين الفوليوم اللي ماشي في السيرفيس رود مع الفوليوم اللي ماشي في المين ستريت. اوكي. طبعا في another example for a weaving segment. خليك معايا هنا. This is a perfect example for a weaving segment. ركز معايا هنا بقى لو سمحت. هنا يا شباب في فوليوم طالع من الرامب دي. في نوعين من الفوليوم، في ناس بتبقى طالعه وعاوز يعمل ليفت تيرن ويكمل وينزل تحت، وفي طالع وعاوز يمشي على المين رود، صح؟ In the meantime we have other volume that is on this direction and some wants to go off ramp and some wants to continue. Okay, that's where we get this shape, but in our case it's reversed. يعني to have this exact shape, this is what we have here. We have volume coming this direction and some wants to go off here. In the meantime, we have volume merging and some wants to continue and make such a U-turn or something. In this case, the weaving segment length will be from here to here. It's 196 meters. Okay. أي سؤال يا شباب؟ Any questions? Okay. So L, that's the length of the weaving segment. N, that's the number.
سؤال.
Yes.
بس كذا 3 minutes بغير الجهاز، بطلع وبدخل.
Okay. N is the number of lanes in the weaving segments. معناها ايه N in the number of lanes؟ يعني بمنتهى البساطة هنا how many lanes do we have here؟ 1 2 3 4. 4 lanes. Here 1 2 3 4 and maybe this is a fifth lane. 5 lanes. So N, we have 5 lanes available in that weaving segment. Okay. Okay. NW, that's the number of lanes to be used by weaving vehicles if unconstrained operation is to be achieved. We'll discuss this later. NW maximum, that's the maximum number of lanes that can be used by weaving vehicles for a given configuration. And NW, this is NW, that's number of lanes used by non-weaving vehicles. Okay. V, that's the total volume, total flow rate in the weaving segments, which is basically the total volume, the total of these all volumes, VA plus VP. There's other parameters here, VO1, VO2, that's what I was talking. VO1, that's the larger of the two outer non-weaving. VW1 is the larger of the two weaving flow rates. VW, that's the total weaving volume. VNW, that's the total non-weaving volume. VR, that's the volume ratio, which is basically the ratio between the weaving volume to the total volume. R is the ratio of the small the smaller weaving volume to the total weaving volume. SW, that's important. That's the speed of the weaving vehicles. SNW, that's the speed of non-weaving. S, that's the average speed for all vehicles in the weaving segments. D, that's the average density for the vehicles in the weaving segments. WW, that's a weaving intensity factor for predicting weaving speed. WNW, that's the weaving intensity factor for predicting the non-weaving speed. Don't be shocked with these, parameters. It's much simpler than what you think. Okay, the first step, we have to adjust the volume. So we have to convert this volume, okay, to the, divided by the peak hour factor and the factor for heavy vehicle, and, convert our flow rate into passenger car per hour, not per lane, by the way, passenger car per hour, okay? as you can see here, we divide the flow rate by the peak hour factor, by the factor for heavy vehicles, and the factor for driver population. Then, this is an example, okay? That's you know, segment and flows. We have continuous flow from A to C, that's 1500. We have from A to D. So let's just start with, you know, dealing with these values. So we have VO1. Okay, it equals how much? VO1. Could someone answer me?
$1,500.
1500. Everybody agrees with that? Okay, VW1. VO1 is basically the highest outer volume, highest non-weaving. Okay? VW1, the highest weaving volume. Where are the weaving volumes here? شباب في points على participate.
500.
500 and 300. So here we have 500. Okay, of course, this is vehicle per hour. Vehicle per hour. And we have VO2 equal 400 VPH. And we have VW2 equals how much? 300. ممتاز. طيب, let's, what is V total? VW, weaving volume, equal how much? 800 vehicle per hour. That's the total weaving volume. صح؟ طيب, V total. كم V total هنا؟ 2,700. That's the summation of all. Okay. We have a ratio here that we need to calculate. VR, volume ratio. VR equals how much? It's basically VW divided by V. يعني VR equal 800 divided by 2700 equals how much?
0.296.
0.296. ممتاز جدا. خلاص, في حاجة تانية محتاجين نحسبها هنا؟ I don't think so. So that's an example how we you know, handle and make our preliminary calculations. Then we go to this one, determine the weaving segment configuration. There are different configurations, okay, for depending on how many lanes the drivers need to shift in order to make the weaving, okay? So here, let me just if there is only, okay, if there is no lane shifts, then it's type B. If there is one lane shift in one direction only, then still type B. If it's one lane shift from one direction and one lane shift from another direction, it's type A. If it has greater than two lane shifts, okay, in one direction, then it's type C. Okay, to give you an example for this and to explain it to you better, let me just share this with you. Hold a second, just bear with me. Oh, هنا يا شباب, what we are saying, if you have if we have a ramp like this one, so basically if someone driving on this lane, in order to weave and change, he must go this way. So here he made one lane shift. The same applies for, if we say this is A, and this is B, this is C, and this is D. So if we just draw it, that's A, C, A, D, and B, C, B, D. The weaving volume is basically this volume, B, C, and from A to D. Okay, as you can see from here, that the volume BC must make one lane shift. The same applies to volume coming from A to D. So that's another volume. Okay. In this case, we have one lane shift and one lane shift. In this case, this would be type A, because we have one lane shift from both directions. Okay? Okay. If the situation changes and we have another condition here, again, we have here A, B, C, and D. We have the volume or the weaving volume from B to C. It must make one lane shift, okay? But the volume from B can just keep going and exit from here. So we have here 0, 1. So this case will be classified as type B. Okay? The case before, this one was type A, because we had 1, 1 lane shift for each direction. Okay? Type. Let's now see how the type C can occur. If we have a freeway like this one, okay, this is A, this is B, this is C, and this is D. So in our case, we have AC, AD, BC, BD. So the weaving volume, BC, we need to make these. How many lane shifts? 1, 2. 2 lane shifts.
2 lane shift.
In order to make that weaving. Okay, so this one becomes type C, and this is the worst case scenario. Here, if it's greater than or equal to, then it's type C. Okay, so each of those categories will have different numerical models to deal with in predicting the weaving intensity. Okay, that's clear for everybody? Okay. Okay, then once we get to that point, once we are done, we have to determine the weaving and non-weaving speeds. In order to do that, okay, there's the equation, that's the SI, that's the weaving, the average speed of weaving or non-weaving, it depends. It's basically the S minimum plus S maximum minus S minimum divided by 1 plus weaving intensity. Okay, here the S minimum is substituted with 24 kilometers per hour. Okay, that's the minimum speed, and the recommended value. This is the recommended values by the highway capacity manual. Okay, which is basically, okay, assuming that the S minimum is 24 kilometers per hour, and the S maximum equals the free flow speed. Okay, so basically that's the recommended values by the highway capacity manual. Of course, some might ask why we are subtracting here 16 instead of 24. Okay, the answer for this is basically this way it's you know, less conservative. Okay, and basically it reflects the situation much, you know, better. Okay, step 4, we have to determine the weaving intensity. الفاكتور اللي هنا ده يا شباب ده اللي هو الويفنج انتنسيتي WI. ممكن نحسب weaving intensity I دي ممكن تكون weaving او non weaving. عندنا 2 types of traffic. We have weaving traffic and we have non weaving traffic. Okay, فالW دي بنحسبها للاثنين وبعد كده بنعوض عشان نجيب السبيد للنون ويفنج والويفنج. Okay, so here we determine the weaving and non-weaving speeds. In order to do that, we have to calculate the weaving intensity, okay, and substitute in that form. In order to calculate the weaving intensity, we have to substitute in this form, and weaving intensity is calculated as the following. A, that's a coefficient, multiplied with 1 plus VR to the power P, multiplied with V over N, okay, to the power C divided by 3.28 L to the power D. Of course, we're going to go nuts now with what's A and B and C and D. The simple answer, these are constants, okay, in this statistical formula, okay, and for weaving speed, we use these parameters in that column. For non-weaving, we use these parameters. Okay, this first part. For the configuration of the weaving segment, if it's type A, we use these parameters. For the weaving and for the non-weaving, we use these parameters. For configuration B, we use these parameters for weaving and non-weaving, and the same applies for configuration C. واضح يا شباب؟ يبقى هنا دي دي الكونستانتس اوف calibration A و B و C و D بنجيبهم من this table. L, this is the length of the weaving segment. Okay, N, this is the number of lanes in the weaving segments. V, that's the total flow rate in the weaving segments in passenger car per hour. VR, that's the volume ratio. Okay, اللي احنا حسبناها من شويه. و WI, that's the weaving intensity اللي احنا هنطلعه. اي سؤال يا شباب so far؟ طيب, it's better with numbers. Okay, so let me just grab these numbers. And let's assume that we have a weaving segment type A. We have these volumes, okay, and the data that we have, we have a weaving segment L equals 250 meters. We N equal 5 lanes. ماشي. We have also here, let's say we have what? We have VR already. Okay. Then let's calculate the weaving intensity. For the weaving volume. W for small w. Equals. Okay, first of all, we are calculating for the weaving volume. So we will be looking here in this area. Okay, and we will assume unconstrained. That means the weaving is done and the drivers are not constrained in their maneuver. Okay, so let's substitute 0.15, that's A, multiply 1 plus VR. VR, how much here? 0.296 that we calculated here. You can see it. To the power B. How much B? شباب 2.2.
2.2.
That's B بالضبط. Multiplied by V divided by N. How much volume do we have? 2700. That's the volume, the total volume. Divided by how much do we have here in number of lanes? N5. To the power of
5 lanes.
To the power of كام هنا C 0.97. And all of this, let me just put a big bracket here. All of this is divided by how much? 3.28 multiplied by L. L 250 meters. And this is to the power of how much? Abdullah Saleh.
ايوه يا دكتور معك.
باور كام هنا؟
ايش؟
كام؟
ما اسمعك يا دكتور.
هنحط باور 0.8. اوكي؟ طيب عاوزين نحسب يا شباب، يا ريت لو حد يحسب الرقم ده. Okay, now we want to calculate the weaving intensity for the non-weaving. For the non-weaving, we are going to put this here, non-weaving. Point how much? 0.0035. We work on this, column. These are A's and B's and C's for determining the speed of the non-weaving. So this is 0.0035, that's A, multiplied by 1 plus VR, that's constant. It's not changing. It's the same. 4.0, that's P. Okay. Multiplied by 2700 divided by N to the power of how much? 1.3 divided by 3.28 multiplied 250 to the power of 0.75. واضح يا شباب؟ The first one how much and the second one how much?
الأول يا دكتور 0.553.
تاني
0.229.
there is something wrong. Because the non-weaving, it's difficult to be less than the weaving.
الأول صحيح دكتور.
Let me just
العمر صحيح حسبت معاه
punch the numbers.
الثاني يا دكتور 6.79.
ما يبقاش greater than 1.
Okay.
Okay, the first one is correct. 0.5359. The second one, .0035 multiply 1.22 to the power 4 to 7 to the power 1.3 divided by 0.75.
الثاني ايوه يا دكتور 0.229.
Yes, it's 2.2229. I'm sorry, I was wrong. Okay. محمد مادة, I'm sorry, I was wrong. اوكي يا شباب, يبقى هنا حسبنا الويفنج انتنسيتي. هنحسب هنا بقى ايه؟ السبيد. السبيد بنجيبها ازاي؟ من المعادله دي. السبيد اس اي بتساوي 24 بلس السبيد للفري فلو ماينس 16 ديفايدد باي الكلام ده. تمام؟ فليتس اسيوم ان الفري فلو سبيد اس فري فلو كانت هنا بتساوي 90 كيلومتر بير اور. يبقى نقول السبيد للويفنج هتساوي، خلينا نرجع تاني بس للقانون اللي فوق ده. تساوي 24 بلس الفري فلو سبيد، افتح قوس، خلي بالك بنعوض هنا بالكيلومتر كيلومتر، 90 minus 16 divided by 1 plus 1.553 1 plus 0.55359. كام يا محمد؟
Uh, 71.6.
How much? 70 71.63.
63.
That's kilometer per hour. Minus 16.
دكتور ال 90 ثابته؟
ما هي دي الفري فلو سبيد بتاعت الطريق. ما هنا
هو محدد لي اياها،
SFF،
يعني ما شفتها من قبل شوي.
هنا SFF ده اللي هي السبيد بتاعت الفري
ايوه
فلو. لو ما فيش حد في الطريق، واحد ماشي بسرعته، هيمشي على هذه السرعة. اوكي؟ divided by 1 plus 1.229 هيطلع كام؟ I'm sorry، مش 1.229، 0.229. هيطلع أعلى من 71.
84.22.
84.22 kilometers.
84.21.
Okay. This is logical, by the way. Okay, and I was confused when I mentioned to you before that the weaving intensity, this should be higher than this. No, here you see that the weaving intensity for the weaving vehicles, okay, was 0.55, which is, it implies that the weaving intensity is higher, okay, than for those that are non-weaving. And it's reflected here in the speeds, which makes sense. Which makes sense, why? Because those that are weaving, they slow down looking for gaps to switch lanes, okay? But those that are going forward, they might be getting delayed due to those are waiting for gaps. مفهوم يا شباب؟ يعني من المنطق ان السبيد للسيارات اللي تبغى تعمل ويفنج، تغير من اتجاهها، هتكون اقل من اللي ماشي سيده. واضح؟
صحيح دكتور.
اوكي
واضح يا دكتور.
طيب هنحسب دلوقتي، يبقى احنا كده جبنا السبيد، الاكسبكتد سبيد فور ويفنج and the expected speed for non-weaving. اوكي طب what's the next step? The next step is to check and to see whether it's، لاحظ معايا هنا احنا الارقام اللي اخذناها كلها كانت في الايه؟ unconstrained. خدنا الفيرست، يبقى هنعمل check to see whether it's really unconstrained weaving ولا constrained weaving. يبقى هنا هنقول determine type of operation. This is what we mean. We want to see whether a number of lanes that must be used by weaving vehicles, okay? And we check if it's less than the NW max, then it's unconstrained. If it's greater than the NW max, then it's constrained. يعني بنعمل تشيك يا شباب ونشوف الويفنج ده هياخد كام لين، ولو وجدنا ان the number of lanes needed for the weaving is greater than the limit، يبقى هنا ايه؟ constraints. يعني case for which NW are unconstrained. Otherwise it's constraints. ماشي؟ طيب هنا قال لك for type A، دي المعادلة اللي بنستخدمها عشان نحسب ال number of lanes required in NW. خلينا ناخد المعادلة دي و let's go back to our example.
دكتور هذا المعادلة.
نعم.
المعادلة اللي انت اخذتها قبل شوية حقت ايش؟
حاجة ايش؟ مين اللي بيتكلم؟
سند دكتور.
مين؟
سند.
سند. شوف يا سند، احنا هنا assumed، لاحظ ان فيها we have two lines here. The first line for unconstrained operations and the second line for constrained operations. الطريقة أو the methodology in the highway capacity manual, okay, there is mode of operation. إيه mode of operation? Constrained or unconstrained. What does it mean constrained or unconstrained? It means that they calculate a number of lanes needed for weaving, for each category, for each type of weaving, okay? And based on this, if the number of lanes greater than the limit, then it's constrained. If it's less than the maximum or the limit, then it's unconstrained. وصلت؟ يعني اللي عاوز اقوله لك ان الطريقه بتاعه الهاي واي كاباسيتي بيفترض ان ايه؟ ان اللي هيعملوا ويفنج دول هيشغلوا حيز معين من اللينز. تمام؟ طبعا ده يتوقف على ايه؟ على الفوليوم اللي بيعمل ويفنج. تمام؟ فهنا تايب A النمبر اوف لينز نيدد، تمام، هو في المعادله اللي هنا. فتعالى نحسبها كده. هنشوف NW هتساوي 1.21 مضروبه في N اللي هم كام؟ 5 لينز multiply VR to the power 0.571 VR اللي هي كام؟ 0.296 to the power 0.571. اوكي، في L الويفنج سيجمنت لينث اللي هو 250 to the power كام؟ 0.234 divided by SW الويفنج سبيد اللي هي 71.63 to the power how much? 0.4 0.438. حد يحسب يا شباب؟ هيطلع 1.69 صح؟ اوكي
يس.
جميل. طيب هنا ده معناه ايه؟ تعال نرجع تاني هنا. هنا بيقول لك number of lanes required for unconstrained operations NW. تمام؟ فاحنا حسبناها هنا. طب for type A because we are assuming that we have type A. Okay? We substituted in this equation and we got what we got. N max كام؟ 1.4. N max هنا كانت 1.4 واللي احنا حسبناه يبقى دي greater than 1.4. يبقى ده معناه ان انا دلوقتي محتاج اعيد اللي حسبته ده كله تاني، تمام، واشتغل على الكوفيشنتس اللي هي في الكونستريند كوفيشنتس. فمحتاج احسب الويفنج انتنسيتي للويفنج اللي هو W فور ويفنج and W فور نون ويفنج. اوكي، وارجع احسب السبيدز تاني هنا. واضح؟ حسبتها سهله مفيش فيها مشكله، واقول لك هتحسبها ازاي. منتهى البساطه. ايه اللي اتغير ما بين between both lines؟ First of all, the constraints instead of 0.15 it's 0.35. فهقول هنا W equals فين ال W القديم؟ 0.553 multiply 0.35 divide by 0.15. W
بس ليه اللي اتغير؟
ايه؟
تغير عندي الايه بس.
مين اللي بيتكلم؟
دكتور
مين اللي بيتكلم بس ما سمعتش اسمك؟ سند؟
اي نعم دكتور.
بص يا سند، هنا بنعمل حاجة هنا في الأول assumed إن هو كان unconstrained، يعني الناس بتعمل ويفنج بحريتهم ما هماش constrained. ده الاسامبشن احنا بنبتدي الأول حاجة unconstrained، وده اللي اشتغلناه. تمام؟ معناها إيه unconstrained؟ معناها إن الويفنج اريا بتاعتهم مش محددين بيها، بيقدر يعمل ويفنج بسهولة وبيسر. تمام؟ جميل. عشان نعمل تشيك على الاوبريشنز بنحسب حاجه اسمها number of lanes required. شايف المعادله دي number of lanes required for unconstrained operation in W. حسبنا المعادله دي طلع لنا كام؟ 1.69 lanes، يعني لين وثلاث ارباع لين كمان. تمام؟ طيب هنا في تايب A قال لك تايب A النمبر اوف lanes maximum 1.4. تمام؟ جميل. يبقى هنا الريكوايرد اكتر من الماكسيمم، يبقى هنا كونستريند، لان الريكوايرد ده مش متاح، المتاح 1.4. يبقى كونستريند ولا مش كونستريند؟ اوكي. Everybody got this point? Great. طيب here we go to adjusting these factors again. 0.229 multiply by how much? It was now the new factor is 0.002. We can multiply by 20 divided by 35. Okay? كام يا محمد؟ Hmm?
1.292.
كام؟ 1.2 وهنا
1.292.
1.292 and the second one 0.13. 3. Okay. That means the new speeds will be يبقى هنا SW new will equal 24 plus 90 minus 16, that's 74 divided by 1 هتبقى 2 بقى 2.292 equal S non-weaving equals 24 plus 74 divided by 1.13 equal
42.75.
42.75 kilometer per hour, and the second value here will be 80. How much?
86.72.
Okay. Now you can see, because it's constrained weaving, so it drops significantly from 71 drop to 42. Okay. Right. What's the next step? We have done here the check for the operation criteria, whether it's constrained or unconstrained. Then we go and we calculate the average speed. Okay, so let me just duplicate this screen. And let me just go here. Let me grab this. Okay. Okay. Now we want to calculate the average speed. So here we have a weighted average. Okay. And what we need to keep from this is basically those speeds. And we need to get back to the volumes. Let's just grab this all together. Let's move here. Let's put this one on the side. Okay, so here we want to calculate the average speed equals the total volume. How much is the total volume? 2700 divided by, okay, the first one, let's open just a big bracket, and we have here VW over SW. How much is the weaving volume? 800 divided by the weaving speed, 42.75. Close this one, plus the volume, the non-weaving volume. The non-weaving volume is 1900 divided by the speed of the non-weaving volume, 86.73. Close bracket. Equal. How much?
66 point.
66 point. Kilometer per hour. So that's the average speed.
66.5.
66.5. This is the average speed in the weaving segment. Okay. Then the next step will be to calculate the density. Okay. So the density here, we have here 66.5. We need to calculate the density. So that's the density of traffic in the weaving segment. Okay. So the density will be equal to V over N, 2700 divided by N, which is how much? 5 lanes, divided by the speed, 66.5. How much, Muhammad?
8.12.
8.12. What are the units? Passenger car per lane per kilometer. Okay. Okay, let's see what level of service we got here. If we assume that we have a freeway, so we are in level of service B. Okay. So this is LOS equal B. مفهوم يا شباب؟ أي سؤال، أي استفسار؟ Okay, we'll take a break for 15 minutes and we'll be back.